Okay, these notes are solving ratios and proportions. Okay, this is your concept number 8. So this is the final concept before you take assessment number 2. So first we're going to just look at the definition for a ratio. So a ratio uses division to compare two quantities. Okay, so we're just comparing two different values. We have 3 different ways to write these. So you can use a colon, you can show it with division, or you can write the word 2 in between them. Okay, these are all said exactly the same way though, A to B. Each one of these is said the same way. A couple examples. So if you're a baker or you like to cook, this is something that you would see often. 3 cups of flour to 2 cups of milk. Okay. So for every 3 cups of flour that you put into a recipe, you also have to put in 2 cups of milk. So if I'm putting in 6 cups of flour, I'm going to have to put in 4 cups of milk, okay? Because for every 3, there's 2 cups of milk. Or for every 5 cows on a farm, there's also 8 chickens. Okay? So if there were 10 cows on the farm, there would be 16 chickens. And the most common is example number 3, 50 miles per hour. This is your speed limit. Okay? You see these all the time whenever you're driving. All that is simply saying is that if you're driving at a speed of 50, that means that you can drive 50 miles in 1 hour. So 50 miles per hour means that if you're driving at the speed of 50, you will be able to drive 50 miles in 1 hour. So if you drove 100 miles, it would take you 2 hours. Okay, now simplifying the following ratios. So a volleyball team plays 14 home matches and 10 away matches. So again, we're just comparing two quantities. So I'm comparing home matches to away matches. So to make that comparison, 14, and I'm using the colon, so 14 to 10. And I'm trying to simplify it, which means I want to reduce this down. So the furthest I can reduce it is by dividing each of those by 2. Okay, that's the biggest value that is divisible by both. 14 becomes 7, 10 becomes 5. So that's my simplest form of 7 to 5. Okay, so that means that if the volleyball plays 7 home matches, they are then playing 5 away matches because I was originally comparing home to away. Then I can compare girls and boys in a classroom. So there were 12 girls and 16 boys. 12 and 16, the biggest that they reduce by is 4. 12 divided by 4 is 3. And 16 divided by 4 is 4. So that is simply saying for every 3 girls in the classroom, there are also 4 boys. Okay, now when it comes to actually solving, which is what we're going to do more often, right, a proportion, right, is an equation that states that 2 comparisons or fractions are equal. So now I'm taking 2 comparisons, okay, and we just looked at 2. I'm taking 2 of them and I'm saying that they are equal. Okay, so to solve a proportion, which is just 2 ratios that are set equal to each other, I am going to use a process called cross multiply. So I cross them by taking one numerator times the opposite denominator, and then the same with the other. I take this first denominator times the other numerator. Okay, so I'm crossing them when I multiply. Now, I normally start with my variables whenever I do it, so I'm going to start down here. It does not matter if you start with the 11 times the 30 or if you start with the 6 times the x, but I will typically start with the variables. So 6 times x is 6x, and 11 times 30 is 330. That equal sign that was in the middle has to stay in the middle. So 6x equals 330. From there, this is just solving an equation like normal. So I have 6x equals 330. This is a one-step equation. In order to get rid of the 6 and move it to the other side, I'd use an inverse operation. So this originally was 6 times x, which means in order to get rid of it, I divide both sides by 6. I do the inverse of multiplication, which is division. 6 divided by 6 becomes 1, so they cancel. 330 divided by 6 is 55, so x equals 55 is my final answer. Another example, same basic concept. I have W over 20 equals 4 over 5. So I have a fraction equal to a fraction. Again, I can cross multiply. So I start with my variables. And again, it does not matter where you start. My variable here is in the numerator, so that's where I'm starting at. W times 5 is 5W. 20 times 4 is 80. And again, your equal sign carries down. So 5W equals 80. Divide both sides by 5. You end up with W equals 16. Okay, now those ones were already written out for you as a proportion. Okay, they were already written as a fraction equal to a fraction. In the next two examples, they were written out in word form, and you need to change them into the fractions. So in the first example, we have 2 is to 7 as A is to 42. When you see the words is to, that's where your fraction bars go. When you see the word as, that symbolizes your equal sign. So 2 is to 7 becomes 2 divided by 7. As becomes equals, and then A is to 42 becomes A divided by 42. Now this is exactly the same as the previous examples. Okay, now my proportion is set up. I have a fraction equal to a fraction, so I can cross multiply. 7 times A is 7A. 2 times 42 is 84. And now you solve it like normal. My goal is still to figure out what A is equal to. So I divide both sides by 7. A equals 12. Then another example, Y is to 18. So Y divided by 18 as becomes my equal sign. 45 is to 10. So 45 divided by 10. 10 times Y, or Y times 10, is 10Y. 18 times 45 is 810. Again, my goal is to solve for Y, so I need to finish this by dividing both sides by 10. I end up with Y equals 81. Okay, so to continue where we were before, we have the next example is 6 divided by 3 equals 8 over x minus 10. Now, this looks initially a little bit different, but you set it up the exact same way. You've just got to be careful. So I normally start with my variable, so I'll start with that. So I have 6 times, but now instead of just one single value here, I have the quantity of x minus 10. Okay, which means this 6 has to get multiplied by both of those pieces. So we show that by putting that x minus 10 in its own set of parentheses. Okay, so 6 times the quantity of x minus 10 equals, and then our 3 times the 8. We still cross multiply the other way as well. So 3 times 8 is 24. Now, because of that 6 times the parentheses, the first thing you're going to have to do is distribute that x. Or distribute the 6, sorry. So 6 times x is 6x. 6 times negative 10 is negative 60. Equals your 24 still. Then it's just the two-step equation. Add your 60 to the other side. Gives you 84. Then your final step is to divide both sides by 60, or by 6. 84 divided by 6 is 14. And another similar example. We have 9 times r minus 3 when I cross multiply. So I put that r minus 3 in its own set of parentheses to show that I am multiplying the 9 times both pieces. Equals, then 4 times 6 is 24. Now you distribute the 9 into the parentheses. 9r minus 27 equals 24. Again, my goal here is to solve for r. I have to get that by itself, so it's a two-step equation. Add 27 to both sides, then divide both sides by your 9. Okay, that's going to end up giving you 51 divided by 9 does not work out evenly, and that's fine. 51 divided by 9 is approximately 5.7. All right, 2 more examples, then some word problems. So we have 2/3 equals x over x minus 1. So now I have a variable in the numerator and in the denominator. So it doesn't matter where you start, you choose. So I started with the 2 times the x minus 1. Again, put that x minus 1 in parentheses. Equals 3 times x is 3x. Now, this is very similar to the previous concept where you are solving with variables on both sides of the equal sign. So you have to start by combining all of those variables on one of the sides. So I'm going to choose to move this 2x to the opposite side, which is going to leave me a negative 2 equals x. 3x minus 2x is just a 1x or just an x. Then you're done at that point because you're down to just a 1x. So x equals negative 2. Okay, another example. N over 8 equals n plus 8 divided by 10. Cross multiply. Again, you can start wherever. I started with the 8 times the n plus 8. So again, the n plus 8 is in parentheses. Equals n times 10 is 10n. Now this goes back to a multi-step equation. 8, distribute that in, you're going to get 8n plus 64 equals 10n. Now this is an equation with variables on both sides. So you have to start by moving your variables, your n values, to the right-hand side of the equation. So this was a positive 8n. I'm going to subtract 8n to the other side. Bring down your 64 equals 10n minus 8 equals 2. Now you divide both sides by that 2. So n equals 32. Now it's important to remember with any of these examples, any proportions at all, you can always check your answer. Plug your answer back into the equation everywhere you see that variable. Simplify both fractions and make sure that when you divide them, they give you the same exact value. For these two fractions to be equal, that means when you plug in your answer and divide, you should get the same exact whole number or decimal, whichever it may be. Okay, so you can always check your answers with these. Okay, now we have two word problems. So in the first one, Shauna reduced the size of a rectangle to a width of 4 inches. Okay, we want to know what is the new length if it originally had a length of 36 inches, okay, and a width of 24 inches. Okay. The best thing you can do with these is draw yourself a picture. So I drew the initial rectangle. Okay. It originally had a length of 36 and a width of 24, so fill those in. The original rectangle had a length of 36 and a width of 24. Now it told us that in the new one, okay, she reduces the size. So if you reduce it, that means it's getting smaller. Okay, so she reduced it to have a width of 4. So my new width is 4. What I don't know, what I'm looking for, is what is the new length. So my new length is x. So 36 divided by 24 is my first ratio. I'm going to do big to small. Okay, so my big rectangle is 36 over 24 equals my smaller rectangle. Now I have to be consistent. In my first one, my numerator was the length. So in my smaller proportion, my numerator has to also be the length. So it has to be x over 4. You have to be consistent. If you do length over width, your new one has to be length over width as well. Now it's just a regular proportion. Cross multiply, you get 24x equals 144. Divide both sides by 24, you get x equals 6 inches as your answer. You need to have units. There was units in the original values. You need to have units with your answer. Okay, then the scale on a map is 1.5 inches to 10 miles. If you traveled 67 miles on a trip, how far did you actually move on the map? Okay, so this is a real life example that you will encounter a lot. So 1.5 inches to 10 miles. Now remember from the beginning that that word to symbolizes your fraction. So 1.5 inches divided by 10 miles. Okay. Now again, you have to be consistent. So when I set up my other ratio, okay, I've traveled 67 miles on a trip. I want to know how far did I move on the map. So what I'm solving for is my numerator. That's my inches. In my denominator, I have to be consistent, was my miles. So I have 1.5 over 10 equals x over 67.